Good evening, everyone. I'm Alan Stolzer, and I have the privilege of welcoming you to Embry-Riddle's Aviation Outlook webinar. This series is sponsored by Embry-Riddle's Deans of Aviation, and our goal is to bring you experts in various segments of the aviation and aerospace industry to discuss the outlook for the industry going forward through this pandemic and beyond. I'm especially excited about tonight. Joining us are Kathy Rice and Dillon Rice, two very knowledgeable and accomplished professionals in commercial space and space flight. Kathy Rice is the weather officer in the Spaceport Integration and Services Directorate, NASA Kennedy Space Center, Florida. She has 29 years of experience as a U.S. Air Force and NASA meteorologist, specializing in military aviation and space launch missions. She served as a weather officer in the U.S. Air Force for 9 years, following on as a civilian meteorologist for the Air Force at Cape Canaveral Air Force Station. Kathy was the lead Space Shuttle launch weather officer for 11 years and the lead Delta IV launch weather officer for 7 years. In 2018, Kathy accepted her current position as the NASA Kennedy Space Center weather officer. She earned a degree in mathematics with minors in computer science and aerospace studies from the University of Central Florida. She holds a certificate of meteorology from Florida State University. She is also an alum of the Harvard of the Skies, earning a Master of Aeronautical Science degree from our own Embry-Riddle. She's a distinguished member of the College of Aviation Industry Advisory Board, and we appreciate her service on that board. Her husband, Dillon Rice, is the launch conductor for United Launch Alliance, responsible for the liftoff of Atlas V and Delta IV rockets from launch pads at Cape Canaveral Air Force Station. Recent launches have included the Solar Orbiter and Parker Solar Probe, Boeing Starliner, and launches for the U.S. Space Force. Dillon has progressed through a variety of roles, from working on infrastructure design at Cape Canaveral Complex 37 to launch operations supporting Delta IV launches to flight operations, and for the past 5 years, he's been responsible for the execution of multiple successful Atlas V and Delta IV launch countdowns at both Cape Canaveral and Vandenberg Air Force Base in California. He holds a bachelor's degree in electrical engineering from the University of North Florida and a master's degree in systems engineering from the University of Denver. So welcome to both of you, and congratulations on your amazingly successful careers. And thank you so much for taking the time to join us tonight. It's now my pleasure to introduce my colleague, Dr. Bob Thomas, who will take it from here. Thanks, Bob.
Thank you, Dr. Stolzer. Good evening, everyone. Good evening, Kathy and Dillon. Thank you for joining us tonight. Before we get started, I want to remind our audience at the bottom of your screen, there is a Q&A button that you can press to submit a question for our guests. We did get a lot of questions already submitted when people registered, and I've worked those into some of the questions I'll ask tonight. But if you have some additional questions, feel free to press the button and ask them below. I'd like to start out with some of your background, if we could. Kathy, we'll start with you. Dr. Stolzer already gave a list of your impressive credentials already, but I wanted to find out from you what made you want to go into the weather, meteorology, and how did you get into space weather and launches?
Oh, well, I was going to the University of Central Florida. I was getting a mathematics degree, and I was an ROTC cadet, an Air Force ROTC program there. And the Air Force has a lot of different career fields that you can go into, and one of them is meteorology. So I actually wanted to know more about it, and I ended up coming over to Cape Canaveral Air Force Station and learning about it from my mentor, John Madura, who was the squadron commander at the time at the 45th Weather Squadron. He totally convinced me to become a meteorologist. He showed me all around, and I was totally hooked. So when I got back to my ROTC unit that day, I said, I want to put in for that as my first choice. And the Air Force had a basic meteorology program. Then if you had enough math and enough physics, then you could actually be accepted into that program. And so I was qualified and did end up going to Florida State for my first assignment for my certificate of meteorology.
That's quite the journey there. So then you were in the Air Force for a while, and then how did you get into switching over to working in the Space Center area?
Well, after I'd been in the Air Force for 9 years, I decided to separate, and so I put in for a position at Cape Canaveral Air Force Station because of what I had seen there when I was in college, and of course, seeing the launches when I was in college. I knew there were meteorologists there, and so I applied, and I was able to get a position there. And after being in the systems side of the squadron for a year, the shuttle launch weather officer retired, and so I put in for the Space Shuttle launch weather officer position, and I ended up getting to do that. That was really amazing.
Well, can you tell us a little bit more about what it means to be the Space Shuttle launch weather officer, and then also how that's different from your current position as the KSC weather officer?
So being the Space Shuttle launch weather officer here at Kennedy Space Center in Cape Canaveral, what you end up doing is all the launch processing, weather support, and then all the way up through launch, and then after the vehicle lands again back at Kennedy Space Center, or even possibly at Edwards Air Force Base. So all the weather products that go out, everything that they need to know to protect all the outdoor operations, such as rolling out to the launch pad, all those forecasts are provided by the launch weather officer. And also it's a whole team there at the weather squadron there. So really it is a team effort. So the forecasters are providing resource protection 24 hours a day, 7 days a week for lightning watches and warnings and winds. But for tailored weather support for specific operations, that's where the launch weather officer's role really comes in. Also on the, of course, launch day, the countdown as well, talking directly to the launch director and reporting the lightning launch commit criteria and if we're go or no go for launch. Now what I do is I actually help improve those lightning launch commit criteria. I worked over, now I took a position over at NASA. I'm the KSC weather officer. And so I also help now improve all the tools that the weather squadron, not all the tools, but a lot of the tools that they use on launch day, but also those lightning launch commit criteria as well. And we have a team of lightning experts that we go to for that, and we help provide all the any information that they need data-wise or anything from our instrumentation. They study that data, come up with what we're trying to do now is actually try to make more refined rules so that we have more launch availability, and any changes to the rules we provide both to the FAA and all the launch ranges. So that's kind of how we tie back in to the weather squadron here at the Cape.
Okay, that sounds interesting. We'll get into some of that launch criteria a little later on. I want to ask Dillon some questions here about your background, and if you could kind of talk about your journey from where you started, like after college, into how you got into the space industry.
Sure. So, you know, I went to UNF and I got an electrical engineering degree there. And really through the net wide, when I was looking for employment opportunities, one of the opportunities that came up was supporting the construction of then what was a brand new launch pad, supporting a brand new rocket down here at Cape Canaveral. And they were looking for some folks to work in data processing and communication, specifically infrastructure design for the new launch pad. So I got selected for that job and moved down here from Jacksonville, and we went to work building a new launch pad for the Boeing Delta IV rocket. So I spent some time there until we converted from a development and construction type of program into an operational launch program, and then I moved into an operational role that became more about maintaining the communication systems and the infrastructure, as well as starting to support some of the mission unique requirements that come along for every mission. And I did that for a handful of years and moved on into what we called flight operations integration, which is a little different phase. It deals more with the rocket in flight. So once the rocket takes off from the launch pad, there are telemetry assets that are locally on the coast and all over the world that track the rocket from the ground and in space. And we bring all that data back real time back to the launch site so that the whole engineering team can really understand what's going on with the rocket and the flight, as well as the spacecraft team, so they understand the status of their spacecraft and when we've turned them loose and they're on their way for their mission. So I did that for several years and then was able to move into the launch conductor's office where I was able to leverage some of my diverse experience along the way to be able to lead the teams through the countdowns now. So that's kind of my journey. In the interim there, I went back and got a master's degree in mechatronic systems engineering, which was fun. It just kind of helped, build the knowledge there.
I can imagine the volume of information that probably comes off the rockets nowadays that is quite astronomical. Could you kind of talk about maybe the amount of data that the rocket actually sends back that everybody looks at?
Sure. So the rockets, we have multiple data rates that we use. So when we're in the early phase of flight, from liftoff through the period of time where we cross out of view of the tracking antennas that are here locally in Florida, we generally run a data rate that can be as high as 4 megabits per second. It depends a little bit on the vehicle configuration, but once we cross out of view of the ground-based assets, we drop our data rate and optimize our rocket antennas. The rocket's got multiple antennas on it that radiate this telemetry. Optimize that antenna selection to the TDRS network in space, which were satellites that the Space Shuttle launched, and then we've launched some additional TDRS satellites as well. But that data comes back down at a lower rate down to the launch sites that allow us to continue that visibility. So the higher data rates can get as high as 4 megabits per second, and then they can get as low as about 300 kilobits per second. But it's quite a bit of data. And if you think about the amount of time the rockets fly, they could, it could be a 1 hour flight to an 8 hour flight. So you think about radiating that data continuously, it's a lot.
Yeah, I can imagine. But your experience both with building the actual launch complex and then in communications probably sets you up really good for being a launch conductor because you have a wide range of background. Now, can you explain exactly what the launch conductor does? Because I know we've seen a lot of movies with the go, no goes. You picture like the big red button that you push to launch the rocket. What exactly does a launch conductor do?
Sure. So the launch conductor is responsible for the overall execution of the countdown. So we have multiple engineers and disciplines that are responsible for, on launch day, for checking out the avionics of the rocket. We've got engineers that are responsible for loading the individual commodities on each stage of the rocket. And there are other engineers that are checking out some of the other ground systems like umbilicals and that sort of thing. So the role of the launch conductor really is to ensure that the entire team, including the spacecraft team, is all marching together to ensure that we're all ready to go when that launch window opens at T0. And part of that is that go no go poll that you hear. We're ensuring that everybody is ready, all the systems are configured for launch, and the launch management team then issues us permission to continue the terminal count to liftoff. People ask about that red button all the time, and do you get to press the red button? And I'll tell you a little secret about the red button. That red button is a stop button. So ideally, we don't have to press that stop button. The terminal countdown is automated for the most part. The last 4 minutes is completely automated. And so in the event that there's some issue that comes up that we need to manually stop the rocket launch for, we'll hit the red button. But yeah, that red button is a stop button.
So in this case, red button is bad. Got it. Okay. Now you mentioned a wide team. Both of you mentioned working with teams, both in the weather and with the whole launch operation. How has the COVID-19 situation kind of affected your operations right now?
We're both mostly teleworking, although sometimes we have to go in for certain things, particularly Dillon. He tends to have to go in a little more often for some operations. But yeah, we've been teleworking a lot more. And so it's different because, I really enjoy, I'm very extroverted. So I really enjoy going in and seeing my team there, seeing the group that I work with. We have meetings every morning where we go over the weather, and then we talk about the operations going on in the center. And that's when we also have a lot of, fun together and good rapport. And we miss that, but I noticed we've been sort of stepping up and having more social Zoom times, some Zoom lunches, or, these times where we can still get together and have that good banter that we have with each other. But yeah, I miss it a lot. But we still are really, it's amazingly effective still how we've been able to stay really engaged, even in this telework situation. We did do a test when we kind of saw it come in. Kennedy Space Center did a test, and it went really well. And so far, we've had a lot of really good fortune when it comes to being able to be connected as much as possible, even in this situation. How about
What's
you?
the size of your meteorology, the weather team? How many people would that consist of?
Well, for the team at the Weather Squadron, we kind of work hand in hand with the Weather Squadron, who is at the Cape Canaveral, and they're about 35 people, mix of military and civilian. And I'm sort of that's kind of not the perfect number, but it's right around 35 or so. And then there's just two in my office, but then we have the whole spaceport integration, which is a couple dozen people that is helping with integrating all the operations that are going on between Kennedy Space Center and Cape Canaveral Air Force Station, because there's a lot of services that Kennedy provides to launches that are even happening at Cape Canaveral, such as commodities. So, so it's a group of us, and we just try to really make sure all the ops are integrated, because certain ops can affect other operations. And when you get launches really close together, we just have to make sure nothing interferes with anything else. And so it's a continuous process that's going on all the time.
What about with ULA, Dillon?
So, we're in a situation where processing the launch vehicles, there's just no way to get around some of the hands-on stuff, and and the control rooms are what they are. So we've been working with the local and the federal authorities, adopting all the safety guidelines you'd expect, with masks and hand sanitizer, and doing additional cleaning of our facilities. But the folks that, on a day-to-day basis, if you're not assigned to a particular operation where you need to be in the launch control center or you need to be out at the launch pad, and you don't have a really good social distancing situation available in your office, we've been doing more teleworking there as well. So we've been trying to take all the smart steps in order to keep things moving, which we thankfully have been able to do pretty successfully, and still allow the team the flexibility to telework when they can, and protect everybody as much as possible. So we've been able to keep things going quite a bit. But one of the things you'll notice on the cameras when you start to watch that Mars 2020 webcast on Thursday morning is that you will see everybody wearing masks. There's a couple of the support areas where we've cut the number of people in a particular area in half, and so you'll see that not all the console positions are utilized, and we've taken other team members and moved them off into areas that you can't see on camera, but we've established ways to make all that happen. So we've done absolutely everything we can to keep everything moving forward.
Well, if we kind of ignore the whole social distancing mask thing for just a second, how many people would be in the room with you when you're the launch conductor for launch?
The Launch Control Center usually has all told about 50 people. There are a number of other rooms with some other supporting folks. Our design engineering team is in a room upstairs we call the engineering support area, and that room has got about 40 people in it. We have another room we call our Mission Director Center. That's for our management team and the customer team. And that room holds, generally speaking, holds about 30 people. So we've got those rooms are a little bit more dispersed now. Those folks are off elsewhere. And then we have back at our design center in Colorado, we have additional folks there as well supporting. And back in Colorado, we can tap absolutely anybody we need to that works for the company. So it could be, listening or supporting any one launch. It's a large cast of people behind the scenes. But in the Launch Control Center, generally speaking, it's 50 to 60 people all told.
And I bet you get a good view of the launch from the windows there too, I'd imagine, right?
Well, we actually have a large video wall. The building where our Atlas Launch Control Center does not have a good window view of Launch Complex 41, where Atlas 5 takes off from. So we do have a large video wall there that provides an amazing view. The Delta 4 Launch Control Center is in a different building up the road, and it does have a much better view of the Delta 4 launch pad, so that's nice. Because it's always fun to watch the windows rattle when you let loose a couple of million pounds of thrust,
Well, let's talk about rocket launches. So we've got the Mars 2020 coming up in a couple days. I thought with both of you in a unique position from the weather and the operations side, we could kind of maybe talk about maybe the week ahead leading up to the launch, how you get involved, and even something, predetermined like the launch window. I know that's kind of in this case, we're waiting for Mars to be in the right spot to launch, but I know the weather plays a big part into that as well. So maybe you can kind of talk about some of the planning and preparation that takes place maybe about a week before launch and as we get closer to the actual launch itself.
Sure. You want to go first?
Okay, so the launch weather officer at the 45th Weather Squadron will start issuing launch forecasts, usually about 4 days before launch. Of course, I'll be talking before that, but that's where the official forecasts start really coming out, and we start getting a probability of violating launch constraints, and that helps the launch team kind of plan. Also, getting ready for any pre-launch operations, for example. Today, the Atlas rolled out to the launch pad, so the launch weather officer was sitting on console, working directly with the United Launch Alliance team and providing weather information that's specifically related to their constraints, and then watching the weather as the operation's happening, reporting anything that might be coming up, like if a thunderstorm started developing in the area, or if there are any other concerns. There's also press briefings, a lot of weather briefings, launch readiness reviews that are going on, and with the team that the weather officer is providing weather briefings for. And then they get their crew rest before launch. There's crew rest rules, so everybody goes into crew rest to be sure they're prepared when they come into work their actual launch shift. And launch day, I always thought as a launch weather officer was like the best day, because you've been talking about it all week, and you finally get to just see what's happening and report the go, no go for the lightning launch commit criteria, and also the vehicle specific launch commit criteria. The other concern that you have also during a countdown is the exposure of the vehicle, because sometimes there's some wind constraints that deal with just sitting at the launch pad. And so those are constantly being updated with the forecast in case there's any risk. And those are particularly a concern if there's thunderstorms in the area, because convective winds can cause issues. So to me, people used to say, is it between Shuttle and Delta, like which was more difficult, or even Atlas? And I always thought Shuttle was sort of easier in a way, because there was, at least when it came to the countdown, because I didn't have to worry about exposure constraints as much. But with Atlas and Delta, there's definitely more concern for the wind exposure. And to me, that was more stressful than actually T0, because you're very exposed. I'll let you go now.
Yeah. So the week prior to a mission like Mars 2020 is very interesting, because this particular mission, the rover is actually powered by a device called an MMRTG, which is a multi-mission radiological thermal generator. It's a small, basically nuclear power plant that we affectionately refer to Perseverance as a nuclear powered dune buggy. So about a week prior to launch, that MMRTG is actually installed in the payload. We actually put the rover and its cruise stage all on the rocket, and the payload fairings are all on the rocket. The very last thing that goes in is that MMRTG. So we seal that up and start closing out the rocket for flight. In the meantime, the crew will conduct a mission dress rehearsal, and that is designed to ensure that the ULA launch team and the spacecraft team are trained with each other when it comes to evaluating constraints and making the go, no go decisions. So that's a training exercise to ensure that everybody's ready. As Kathy mentioned, we start our launch readiness review process. And so NASA has a review that they conduct, ULA has a review that we conduct, and the Air Force also has a review that they conduct to ensure that all facets of the mission, the rocket, the payload, the supporting range, the Air Force Eastern Range, is all ready to go. So all that is happening in the couple of days leading up to launch. Today was roll to pad day, if you saw that on Twitter. So there were some pictures posted out to social media. So here we are 3 days prior to launch, 2 days prior to launch, and we've rolled Atlas with her payload out to the pad. And the launch window opens at 7:50 on Thursday morning. The countdown is about a 6-hour countdown. So the team will be getting on console shortly after midnight on Thursday morning. In order to make sure everybody's adequately rested, we have a crew rest day in there. So Wednesday will not be a day of work for the primary launch team. But that takes you right up to the initiation of the countdown at just about T-minus 7 hours. And then we load the vehicle with fuel and make sure she's ready to go one final time and launch it toward Mars.
So I imagine there's lots of cups of coffee that go on between midnight and 7:50 on launch day.
I'm definitely a coffee drinker. He's probably more Diet Coke.
Yeah, but there's a lot of you hear a lot of talk about how much liquid hydrogen or liquid oxygen the rockets hold, but it also takes quite a bit of caffeine to in various forms to launch a rocket.
Now you mentioned a little bit about training, and I was curious, how much training or practice dry runs will you actually go through for a launch? And does something like the Mars 2020, because it's a little more higher profile, if there's any more extra practice that you would go through versus something like a GPS satellite or something like that?
Sure. So each of our customers has a little different training regimen that they do. And we have internally, we have a different type of training that we do for our engineers and console operators. But generally speaking, we do what we call integrated crew exercises. There are usually 1 to 2 of those per mission. And then in the final days leading up to the launch, we'll do what we call a mission dress rehearsal, which is 1 of those per mission. Some missions will ask us to do a wet dress rehearsal, which is a full countdown of the vehicle. We'll load the vehicle with all the cryogenics. We'll have the entire team on to do that. And that really, it tests and trains the team, but it also checks out all the vehicle hardware. We did that for this mission actually to ensure that the rocket was completely ready to fly before our Mars window opened up. So there's quite a bit of training that goes into it. We ensure that everybody is comfortable with their roles and with their systems and how they communicate and all that sort of stuff, and make sure that we're all working together properly as well. So there is quite a bit of training. It varies a little bit between the Air Force and NASA and our commercial customers, but we do have a pretty thorough training regimen that we go through prior to each mission.
Well, I know as we get closer to launch day, I think the weather, it helps that the launch window is at 7:50 in the morning for thunderstorms. But I was going to ask, we hear a lot, 60% go for launch. Could you share, Kathy, some of the criteria of what goes into actually allowing the launch to happen, whether it's upper level winds or lightning, just that kind of go into that percentage so we can have some meaning to what that number stands for?
Sure. So there's different there's the same lightning launch commit criteria for all the vehicles, and then there are also what we call user launch commit criteria, which are specific to a vehicle, and even within that vehicle, like let's say an Atlas, they can be different just from configuration to configuration of the Atlas. So there's winds, there could be temperature constraints, there could be some vehicles you can't fly through precipitation. Those are examples of constraints that are specific to a vehicle. And then there's the lightning launch commit criteria, which are the same for all vehicles. And anywhere in the US, if you launch a rocket, if you have an FAA certification, you're following these lightning launch commit criteria. Now that has to do with clouds and different types of clouds. What we're trying to protect for with those is triggered lightning. So a vehicle can actually trigger a lightning strike on a launch. So even if you didn't have any lightning in the area that was natural lightning, you may have an electrical field that could build up within clouds. And if they're a certain thickness, a certain, if they have enough precipitation or ice particles in them, once you get to that level, if they start getting into that level of the atmosphere, then you start dealing with electrical fields building up. Now you can launch a rocket and actually create a lightning strike with that rocket. And we've done it twice here on our range. Both Apollo 12 actually triggered a lightning strike on launch, and also an Atlas Centaur back in 1987 triggered a lightning strike. And actually that event is what caused us to actually redo all these rules with a new lightning advisory panel that was created at that time, which we still have today. And they're always now working and improving on these rules. Initially they were created and they were very conservative, and then we've been refining them over the years to bias as much launch availability as we can given the weather.
Is there any different criteria between a manned launch versus an unmanned launch, or even something that's going to Mars instead of just low Earth orbit?
Usually that would be more specific to that vehicle again. So that would be a specific constraint for that launch that is different than, say, the lightning launch criteria. You also might have offshore abort weather issues. So they'll be watching the waves offshore because they want to make sure if the capsule has to abort off the top of a rocket that the waves aren't too high, or if there's a recovery operation that has to occur, their waves are something that's taken into account. Offshore weather can be an issue. And then you mentioned upper level winds. There's not like a specific wind speed. It has to do with wind shear compared to the trajectory. So that's really calculated by the customer. We provide the upper level winds, and then they determine if the trajectory is good for launch. And that can be different, of course, from any kind of trajectory, whether it's manned or unmanned. But for manned, the thing we really deal with the most is that offshore weather. That's the big difference that we notice.
Yeah, in case there's an abort. Well, that makes sense. Now, and maybe this is a question for both of you. I know that ULA has a unique way of incorporating the weather almost during the launch to adjust the trajectory of some of its rockets. How does that feed in? And could you share some more about how that actually happens right as the rocket launches?
Sure. During the countdown, we're getting data on those upper level winds from the weather team, and our engineering team, our flight dynamics team, is going to be evaluating that data against basically the steering capability or the control authority of the rocket. So the Atlas V, for instance, we have multiple configurations of the Atlas V. We have our standard 4-meter fairing and our larger 5-meter fairing. We could have anywhere from 0 to 5 solid rocket motors on an Atlas V. So each one of those has a little different flight characteristics and a little different steering capability. So our flight dynamics team is taking that wind data, that wind shear data, upper level wind data, real time, and evaluating it against the steering capability for a given configuration rocket. And once we've watched that basically all through the countdown, from the start of the countdown at about 6 hours prior to launch, up to about 20 minutes prior to launch, our team will have gotten comfortable with the weather conditions, and they will have taken that upper level wind data, and they'll load it into the guidance computer just a few minutes prior to launch, so that the rocket knows what's coming and it can optimize its flight path through that wind shear to ensure that we have a successful flight. And what that allows us to do basically is to reduce the dynamic loads on the vehicle during flight. So we are watching it all through the countdown, and then about 20 minutes prior to launch, we load that data into the guidance computer so that Atlas and Centaur know what's ahead of them.
Now, this rocket going to Mars, does it have any difference in terms of a launch just going into low Earth orbit or geosynchronous transfer orbit? Or is it just a matter of how much fuel and weight you can actually carry up at a given time?
Sure. So I'll just preface this. I know that Embry-Riddle is a school of aerospace engineers. I'm an electrical engineer, but I can take a shot at it. So a low Earth orbit for us typically is a kind of a direct injection thing where you'll watch the rocket lift off. We'll have the first stage. We'll turn the second stage loose, and we'll have basically one burn of the second stage that gets us into a low Earth orbit. That's your orbits like the International Space Station. It's also orbits that, for instance, the WorldView satellites that are taking pictures for instance, Google Earth or some of the other services might go to low Earth orbit. Communication satellites, commercial communication satellites, that they could either be going to a geosynchronous transfer orbit, and that type of orbit would be one where we would have one burn of the first stage. The second stage would do one burn and put that in a what we call a parking orbit. You'd have a coast up to apogee, and then you'd have another burn of the second stage that would increase that orbit, and then we turn the spacecraft loose, and the spacecraft uses their own propulsion to get them where they want to go. The geostationary orbits are typically 3-burn missions. So after that transfer orbit that I just talked about, there's a third burn that would circularize the orbit and put you in a fixed spot relative to the Earth's surface. So that's really good for a communication type satellite that maybe is relaying a soccer game from across the Atlantic over here, and that satellite doesn't move relative to the Earth's surface. But for Mars, Mars is all about escape velocity. So we lift off, and we put the second stage and the payload into a parking orbit, and we coast until we are properly aligned with Mars, and we start that second stage back up. And at that point, it's pretty much all about acceleration. So we're getting as much velocity as possible to establish the payload on a hyperbolic escape orbit toward Mars. And the idea there is that if you think about the Earth and Mars traveling around the sun, Earth kind of has the inside track, and so Earth is lapping Mars about every 26 months or so, 26 months. And that's when that period when Mars and Earth are aligned is the kind of the shortest distance between between the two planets. So we want to launch right then so that the Mars payload gets into the Mars orbit around the sun at the same time that, you know, it basically meets Mars in that orbit, if you will. And not only that, so if you think about all the math associated with that, that's incredible. But we also designed that trajectory such that when it comes time for the Mars 2020 package to land, it lands in view of assets that NASA already has around Mars, so that NASA can watch and listen to the telemetry as Perseverance makes the descent toward the surface. So it's you know, that it's just an incredibly complex amount of computation to make all that happen. But that's really the difference, I think, in the different types of orbits, is the where those burns occur, how many burns you have. And then we are going to do a third burn for the Centaur when we turn the Mars 2020 payload loose, and that is to make sure that the Centaur doesn't follow Mars 2020 all the way to Mars. So we're going to just do one more little burn to scoot Centaur out of the way, and so that Centaur doesn't follow Mars 2020 all the way to the red planet.
So it'll just kind of drift off in space for a while then after
Goes
that.
into an orbit around the sun.
I imagine the computers and the team who does all the calculations for that is quite a hefty computing power center to do all those calculations.
They have a lot of great tools, and it's a really great team. Our flight design team is amazing. Some of the work that they do, and yeah, they have some big computers and some great software tools that they use to work all that out and give us a 2-hour launch opportunity to make all that happen.
Now, I know looking in the Atlantic, there is some things starting to brew a little bit. And I was going to ask our local weather expert here if there's any chance that could interfere. And is there anything special you would do in a situation like this where we do have the potential for some tropical weather to form?
Well, as us weather folks like to say, the best place for a payload when a hurricane starts coming is to get it up into space, get it out of here. Yeah, we would have to deal with that if it started to come. It's not going to be an issue if we launch on time. It would only be an issue if our launch started to delay for some reason. And then, you know, the storm started coming towards us. Right now, it is forecast to come our direction somewhere late in the weekend or maybe the beginning of next week. And it's still a lot of uncertainty in the forecast. So right now, we kind of watch for certain, you know, we have like timelines for decisions. So we have these hurricane conditions, and we will start following those. And so for Kennedy Space Center, we start getting concerned when we start taking action when the storm is 72 hours from giving us 50 knots of sustained wind, and we start taking actions. Before that, we'll do some pre-actions that you know are easy to do and aren't impacting anything. And then the first hurricane condition doesn't usually affect the launch. It's when we start getting down into that 48-hour point. 48 hours before the arrival of 50-knot winds is when we start needing to take some actions that could impact the launch countdown. So all that would have to be coordinated, of course, and decisions would be made based on, you know, on that and how close we were to launch and where we're at in that sequence. But safety, of course, is a big important thing, and keeping all the assets and the people safe is a big deal. So we have a lot of procedures in place for this situation.
Okay. Hopefully it won't interfere with this launch.
Yeah,
what I'd like to talk about, we do have a speed round coming up in just a minute, but I kind of wanted to talk a little bit about how our students and anybody interested can start to have some opportunities, maybe following similar career paths to what you've both gone down. So I was going to ask and see if there's any advice you would give, such as internships, or does a student need to get experience? I know, Dillon, you said you worked for a little while, then went back and got your master's degree. If that's preferred, or if you could kind of share some advice on how to follow in your footsteps down the similar career path.
Sure. So I think that so number one, the internships are great. You know, we have a intern program that we're really proud of. We try to give our interns a really immersive experience, exposing them to as much as we can within our design center, as well as the factory where the rockets are built, and here at the launch sites. So we try to, as much as possible, provide an immersive experience for the interns so that they can experience as much as they can within the business and really think about where they, you know, where they might, you know, work out, where they really want to be within the career field, So we try to give them as big experience as possible. So the internships are great. I think that, as far as the degrees go, the bachelor's degrees are requirements. The master's degrees are great also. It doesn't really matter if you have one coming in, or if it helps if you have one coming in, but if you go back and get it later, that's great too. But really, it's about your experiences. Our CEO actually just recently posted on Twitter. Somebody asked him how he got to where he is, and he said that he always was running toward the difficult problems. And so, one of the things that good mentors do will push you out of your comfort zone and push you toward difficult things so that you can grow and you can achieve great things by dealing with big problems. So that's some advice I would give to prospective students, is run toward the difficult problems. And then the other thing I would say is that the extracurricular things that you do, I know there are teams that build robots, or they're building the solar powered cars that take off across the desert, and stuff like that. All those team projects are wonderful experiences that really result in well-rounded candidates for jobs.
NASA also has a great internship program. In fact, just in our office, we have an intern this summer that was using radar data and running it through an algorithm that she created that will actually help distinguish the difference between the different type of clouds that we evaluate for lightning launching criteria. So in the future, that could open the door to having an algorithm that would do the lightning launching criteria evaluation. One of the difficult things about that algorithm is distinguishing an anvil cloud from a thick cloud from a cumulus cloud. How do you do that in an automated way? And she's come up with something that may work. And those type of internships that NASA has, I think, are just phenomenal. It's also a way to possibly eventually work for NASA one day.
Well, Dillon, you brought up one of my next questions, which was mentors. And I was going to ask both of you if you had anybody in particular that served as a mentor during your journey.
Okay. Yes, definitely. I mean, well, it starts off with my parents. Both my parents. My mom is a nurse, and she was always very persistent in that while she was raising 5 kids. So I think I got my persistence from my mom, but I think that's really been a big part of how I've gone a long way. And also, my father was in the Air Force. But he was retired before I was born, but we were always going to air shows and the Air Force Base for something. And so I think that's definitely how I ended up going into the Air Force and getting really interested in the Air Force. And then when I told you how I met John Madura, a meteorologist that was the squadron commander here when I was a cadet at UCF, he really convinced me to be a meteorologist. So when I actually came back to work here at the Cape, I told him, I said, it's all your fault that I'm here, So I actually ended up working with him again when I came back here to the Cape, and he still mentored me through that whole time, really constantly, providing advice that was just great. And then I would also say Mike Leinbach, the launch director for the Space Shuttle program, he really, he has a way of really building a team and also pushing people to their highest skill level, and I really felt like I learned just a ton from him and working with the Space Shuttle team. How about you?
Yeah, I've been fortunate to work with quite a few people that were willing to offer me up some opportunity and then push me in some certain directions that really helpful. I don't know if I would call out anybody in particular, but because the list is long and I wouldn't want to leave anybody out, but I know that I've been given a lot of opportunities over the years as I've moved from job to job, and I'm very appreciative of that. But the roles of the role of the mentor is really important. You can learn a lot from just watching people, but the good mentors will put you in situations where you have to rise to succeed. So I think that's really important, and I've had that happen in my career on multiple occasions, and I'm thankful for it.
Well, thank you. Let's talk. Let's switch to the speed round now. So there's some quick questions for you both. Dillon, I'll start with you. What is your most memorable launch experience?
We've had so many great missions. It's going to be a short answer. We've had so many great missions, but the one that jumps right at me is the inaugural launch of the Delta IV Heavy. I mean, it's just such a massive rocket. And when that thing started moving, man, it was incredible just absolutely incredible to watch.
Flames came all around the vehicle.
It's absolutely just an incredible machine. So I think that's the short answer.
Okay, Kathy, what about you?
I think it would definitely be a space shuttle program, but I think the most memorable is it wasn't actually a launch, though. It was a day we were making a decision with the vehicle was rolling back from the launch pad for a hurricane, and we made one final weather briefing because the storm that was coming wasn't intensifying as it was expected to, and we had to do this the most crazy weather briefing I know I've ever been in, and they actually stopped the space shuttle and decided to go back to the pad, and it saved the launch window. There was a launch window of so many weeks, and we ended up launching right at the end of that. But if it had gone all the way back to the VAB and then gone back out, it would have been a couple of shifts, and we would have been after the launch window. So saved the launch window, but it was definitely the most difficult weather briefing I ever did in my life, for sure.
All right, what is your favorite place to watch a launch from?
I definitely think work, where we work, at least for me. I like I like being on the roof of the Morale Operations Center at the Cape and seeing the launch from there with the Launch Weather Team. That's my favorite place to watch a launch.
I love watching it from the control center. We have all the cameras at our disposal to watch the rocket. Plus, we can watch the tracker cameras as the rockets fly away. But any rocket launch you can see is a good rocket launch. The viewing along the beach is absolutely amazing, and on a clear evening, the coolest time to watch a launch is really right as either right at sunrise or right near sunset when the rocket takes off in darkness and then crosses back into the sunlight. It's just, you get some absolutely stunning visuals when you see that. So I think my favorite place to watch a launch is anywhere I can watch a launch.
Now, I know both of you work in a pretty historic area with, all the NASA space history and all the history of the Cape. Is there anything that you enjoy, like something unique about that area that you find interesting?
I guess I love to go to the KSC Visitors Center. Sometimes we get to go to these events where we have, the event right under the Atlantis orbiter that's there on display. I just think that they've done an amazing job with that display. And when you go there, even though I've been out at the launch, out watching the vehicle, I've walked right by the shuttle while I was rolling out to the launch pad and all that. But when I go there, for some reason, it just gives me chills, whenever I see it. And so I love when we get to do that.
Yeah, this whole area is great. I mean, there's lots of activities outdoors to do, and just some really nice places. And then when you drive on the base though, and you're driving past all these historical launch pads, the old Mercury and Gemini launch pads, the shuttle pads where so much amazing history happened, and obviously Apollo launches before they were shuttle launch pads. There's just so much history in this area, and it's hard not to enjoy it. There's just so much to check out here. It's great.
So we got two more questions for you here submitted by our viewers. The first is ULA has a new rocket, the Vulcan, coming out very soon. Could you talk about that and how it's different than the previous versions?
Sure. So the Vulcan Centaur is an evolutionary step for us. So we're going to be, the first stage is going to be using liquid natural gas. So that is a new propellant for us. We're teaming up with Blue Origin to use some new Blue Origin first stage engines. And really the Vulcan is all about reducing cost while increasing capabilities. So we're going to have essentially the lift capability of a Delta IV Heavy with a single stick rocket, which becomes a rocket that's easier to process and essentially a lot more capable. But we're also, when we make these evolutionary steps, we're also taking advantage of manufacturing, additional new manufacturing techniques, things like additive manufacturing and that sort of thing to to reduce cost and build things that we build structures in ways we haven't been able to build them before that may give you the same structural capability at a lower weight, or it may be a part that becomes cheaper to manufacture. And that's but Vulcan Centaur really is there to kind of pave the way into the future. We're looking forward to supporting the commercial markets and the additional effort to support the Artemis program with the moon shots and more Mars work and all that sort of thing. So, but really the Vulcan is a kind of an evolutionary step, taking advantage of new manufacturing processes and the new liquid natural gas engines. And so that's the quick version.
I know there are some videos on YouTube out with the CEO giving a tour of the actual production facility and talking a lot about it. And if anybody hasn't seen those, I definitely recommend, because they go into some pretty interesting detail on how they actually build the rockets during those videos. Next question is for both of you. How did you meet?
Dillon was talking about that inaugural launch. I think that's the first time I probably met him, but I didn't know him very well at all way back then. So then later, when I became the Delta IV launch weather officer, we had worked a launch one day, and then I was on console, but not with Dillon particularly. I usually talk more to the range coordinator, but we went out, the launch weather team went out afterwards to a restaurant, and the ULA team happened to be there too. And so I got to talking to them because I had just been their launch weather officer all day on console, and I really noticed Dillon's great sense of humor. I just really did, and it took me a while for me to convince him, a few months, to finally ask me out. I was trying to drop all these hints, and so finally one day I invited him to one of our squadron socials. Yeah, right. And so finally he got the hint, I guess, because he finally did. Our first date was we went and saw The Martian, that movie, The Martian. we had a blast. We had a blast with that.
Everything space related.
Right.
True.
Some other silly questions for you, Dillon. We hear that you're a big Star Trek fan.
Yeah.
What are some of your favorite Star Trek episodes?
So, oh man, that's a good one. There's an episode in the original series where the Enterprise goes to this planet, and they go into the city, and they find that the city looks a lot like Chicago in the 1920s. And as it turns out, there had been another ship that had gone to that planet previously and crashed, and the inhabitants of that planet found a book about the Chicago mobs. So they basically patterned their whole society after the mobs of Chicago in the 1920s. And Captain Kirk and Spock and McCoy find themselves in the middle of a gang war, basically, or a mob war, and they have to go sort all that out. So I think that's one of the coolest Star Trek episodes ever. It's, because I remember Captain Kirk with the Tommy gun, and they're all in the old style pinstripe suits. It was great.
All right. Well, last question for you. Have either of you ever played Kerbal Space Program and built your own rockets?
I have not, although the closest I came to Kerbal Space Program is I used to work with Satellite Toolkit a lot when I was working in flight operations integration, and we used that for not only the Dale launch animation, but also we did some RF link analysis work and stuff with that. So I think the closest I came to it was Satellite Toolkit, but no Kerbal Space Program.
All right. Well, we're running out of time, so I'd like to thank you both very much for talking with me this evening and sharing your experience and knowledge and our advice for our current and just graduating students. And with that, thank you very much. And I will pass it back over to Dr. Stolzer.
Thank you, Bob. And I have to say, I remember that Star Trek episode very well. I loved it. That was a fantastic one. Kathy and Dillon, that was absolutely amazing. Your explanations of what you do leading up to the launches, really enlightening stuff. I'm totally envious of your view of those launches. And Dillon, I love the comment about running toward difficult problems. That is great advice from your CEO. So thank you both so much for joining us tonight and sharing your insights. I'm also excited to announce that our next webinar guest is none other than the Honorable Robert L. Sumwalt, Chair of the U.S. National Transportation Safety Board. He's going to give us his perspective on aviation safety, the pandemic and recovery, as well as a host of other topics. That webinar is scheduled for Wednesday, August 12th, and you won't want to miss it. Mark your calendars. Thanks for joining us this evening, everyone. Good evening and stay well. Thank you.